Hello dear student, this is Devangsha from LG Institute of Engineering and Technology under the LG University. So in our today's topic we are going to discuss about the sequential circuit. So far what we learn about the combinational circuit. Again I consider as a flip-flop. This is the same, the circuitry is like a latch where again you can have a set condition, reset condition and invalid condition where you apply for the part of the feedback is kind of inputs are 0 0. Again you can check this particular truth table, and from this truth table you can have like s is equal to 1 and r is equal to 0 when the clock comes. As such there is a no clock, but if s is equal to 1, r is equal to 0, q goes to 0 and q dash gets to 1, that condition you can consider as a set, and vice versa, right? So in most of the cases when r is equal to 1, s is equal to 0, your q goes to 0, this condition we consider as a set condition, right? Again there are different application of SR flip-flop. Why? Because SR flip-flop is the fundamental flip-flop. So from that, the most important application of this type of sequential circuits is that they are used for switching on a simple circuit which work on set or reset mechanism, right? So normally we use this kind of flip-flop for set and reset conditions like a switching conditions. The example of such circuit where they are used is switch debounce circuit. These are also used for eliminating a mechanical bounce of the switching present in a digital circuit. So it is also used as a digital latching delay. From that we can be able to reconsider our SR flip-flop design in another way. Now there is a limitation of SR flip-flop or a latch is that if there is an invalid state, either both are 1 1 or 0 0. See, I'm never want that particular input signal, right? Either you can set s is equal to 1, r is equal to 0, or you can set s is equal to 0 and r is equal to 1. By this way, see, you can eliminate either 0 0 0 or 1 1 condition, right? And by making this, you can design one more flip-flop that is called the delay flip-flop, and in another sense it is called the D flip-flop. You can see the gated SR latch or SR flip-flop is already there. That what part we have already discussed. What I did with this S and R, I have combined together and put it one inverter or put in one NOT gate in between. So once I putting the NOT gate in between, see, you are never going to have this condition in a truth table. It's like 0 0 and 1 1, right? If you take data D is equal to 1, see, S becomes 1 and R becomes 0. If you take data, I mean input signal is 0, see, S becomes 0 and R is equal to 1. So you are never going to have S and R both simultaneously 0 0 or 1 1, right? Based on, again, if you follow the same truth table of SR flip-flop, see, you can have this kind of terminology. When 0 clock, nothing is going to be happen. When 1, there is a H triggered 1 clock 1 comes. If D is equal to 0, say output becomes 0. Why? Because if D is equal to 0, you can see the set pin is 0 and reset pin is 1. In that case, your Q becomes 0. So this condition is called the reset condition, right? In other way around, if you take D is equal to 1, so S is equal to 1 and R becomes 0. So in this case, your Q becomes 1 and Q bar becomes 0. This condition is called the set condition. So using this D flip-flop, you can have only two state, either set or reset condition, right? There is no invalid condition in between. So that's what the importance of D flip-flop. We are using this kind of D flip-flop, making of the counter. So let's discuss the application of this D flip-flop. A synchronous D flip-flop used as a data synchronizer. The main use of D flip-flop is a frequency divider. If the Q output on D flip-flop is connected directly to the D input, giving the device closed loop feedback, successive clock pulses will make the bistable toggle once every 2 clock cycles, right? The D flip-flop can be used to create the delay lines which are used in a digital signal processing system. So synchronous D flip-flop is nothing but an input delayed by 1 clock signal. So by cascading n such flip-flops, see, you can add more delay, right? So ultimately here, once you are going to connect these D flip-flops in a serially, see, you are going to increase the delay. So normally with D flip-flop we are using to generate the delay, right? We can also use this D flip-flop as a event detector. So one more term, now after D flip-flop we have to understand about the JK flip-flop. What is this JK flip-flop, right? See, JK flip-flop, again we change in a design, and what we did, see, the SR flip-flop, the basic criteria is as it is. So this is what my primary cell is. Now you can consider set pin I have taken as a J and reset pin I have taken as a K, right? But what I did here, see the input I have taken the NAND gate. The first two NAND gate is nothing but the 3-input NAND gate, right? So one input of the NAND gate is clock. Another input we can consider as a set or J pin, and the third input is nothing but based on the previous output state. That's what I have taken as a Q bar as one of the input for first NAND gate. You can check the another NAND gate is nothing but the one of the input is a clock, another input is a K, and the third input is nothing but the Q, which is depends on the previous output stage, right? So based on that, again you follow the truth table. See, you have fourth condition like 0 0 0 1 1 0 and 1 1, and set and reset condition remains the same. One condition you can always have a kind of no change. That means the previously whatever you have a status of Q and Q bar, that remains the store even in the next stage. So this condition is nothing but to store the one bit of information. As well as one interesting thing, once you are going to apply both J and K as 1 1, when the clock comes, see this condition, if previously Q is equal to 0, it becomes 1. If the previously Q is equal to 1, it becomes 0. This condition is called the toggle condition. So again, toggling function you are also going to get in a JK flip-flop, right? There is no change, that means it's just a option for a memory. If both J and K are 0 0, right, there is no change in output. So the output remains the same as the previous output, right? Again, when J is equal to 1, K goes to 0, this condition is the set condition, we already know this. And if J is equal to 0 and K goes to 1, this is called the reset condition, right? Now what is the problem here? See, problem is that, see, one of the input for first two NAND gate depends on the previous output. If clock comes first, and then after one stage, if you're going to get Q and Q bar at the two NAND gate inputs, see this condition we define as a race around condition. Race around is condition is that clock comes first, and after that the previous output signals coming. That means, see, what when clock comes, the signal is directly taking the previous output, and based on that you can always have between the clock, see, your output generate a race around condition is continuously blinking like 0 1 0 1, and you after some time you'll have a stable state, right? So this condition is called the race around condition. That means two signals, or you can consider three signals, are not coming at the same time simultaneously. Because of that, it will generate a kind of race around condition, right? So to remove this race around condition, we have to use a kind of master slave JK flip flop, and this is one of the very interesting design you can see later on, right? So based on this block diagram, you can again define like J is one of the input, K is one of the input. With the application of clock, you're going to have Q and Q bar. So you can see here, previously you can also go for D flip flop, where you can see a kind of block diagram of D flip flop where one of the input is D. In the application of clock signal, you have a two outputs, Q and Q bar, right? The same case you can also consider with the S and R flip flop or RS flip flop. Now everything again based on the fundamental of R and S flip flop, right? So further we will discuss about the application of J and K flip flop. So this is what a application of J and K flip flop, where we use this J and K flip flop. So J and K flip flop is nothing but the universal flip flop that makes the circuit toggle between two states. It's widely used in, see, this is a very important application. It has a capacity to toggle the input first thing, as well as it will also give you the kind of memory state. It will also give you a set and reset state. So it is a universal use, you can consider as like you can use in a making of shift registers, counters. Then it's a pulse width generator or pulse width modulation. In that technique you can use the JK flip flop, and you can also use in many computer application. Now further sequential circuit we consider as one more flip flop, which is called a T flip flop. So T flip flop is nothing but J and K. I'm just short it out. So once you just short it out, J and K, see, you have replaced your set and reset these two states. Why? Because set and reset is nothing but one of the input is 1 and another input is 0, right? And either way, right? But here, as long as you just short the one input is J and K, it becomes the toggle. So it can only perform two states. One is either toggle or there is no change. So one is as a memory and another one is a toggle. That's why this T flip-flop normally we are using as a toggle purpose. That's why it is called the toggle flip-flop, where you can see the complete term is as it is, where T is equal to 0 0. That means here J and K both are 0 0. Your output is 0 and then again 1. This condition we can consider as a no change condition, because previously Q is equal to 0 and 1. With the application of T is equal to 0 0, see the next stage, there is no change in the data. So this stage is kind of memory stage where you can use this T flip-flop to store the 1 bit of memory, right? Same way, if you apply 1 1, see it will toggle the condition. So if you apply 1 1, check the previous stage when Q is equal to 0 and Q bar is equal to 1, or Q is equal to 0 and 1. See, in a next stage, if Q is equal to 0 in a previous state, in next state Q is equal to 1. Now this condition is called the toggle condition, where toggling is just 0 to 1 and 1 to 0. Now why this is very important, because here you can divide the frequency using this T flip-flop. So normally we use this kind of T flip-flop as a frequency divider. See here a kind of T flip-flop where we apply toggle or trigger the input, and you same the application of clock, you are again going to have Q and Q bar, right? So that's what the block diagram of T flip-flop, and from that you can be able to understand. The next one is the application of this T flip-flop. You can use this in a many counter designs. Like these flip-flops are used for constructing the binary counters as a frequency divider, just we have discussed, because it has the features of toggling. So if you use more T flip-flops is always divide by 2. This concept you can use as a frequency divider. This type of sequential circuit is to present the binary addition devices. It is also used to 2-bit parallel load register. So we can use this T flip-flop to make the registers, to design the registers, and it is also used in a shift register. So the last topic we can define as the master and slave JK flip-flop. Now, at earlier we have discussed about the race around condition of JK flip-flop, and this particular limitation, see this particular drawback we have removed, we have overcome by making the master and slave JK flip-flop. Now you can see the design of this master and slave JK flip-flop. See, this is one of the slave latch, this is one of the master latch, where you can see the in JK flip-flop, see first two NAND gate depends on total three inputs. One is the clock, another one is either J and K, and third one is nothing but the output of the previous stage. So for first one J, you can take the output is Q bar, and you can use this one of the input in a first NAND gate. Same way, the output of Q of the previous stage you can take for the second NAND gate, right? Now this is very much interesting, because see, it will again will take one more clock cycle to give the proper output. Why? Because in between we have taken two stages here. One stage we can consider as a master, they can change the data, and slave, you can check the slave will be triggered at the negative H clock signal. So first the positive H clock comes, so the master will be enabled and will change the data, and after positive H, so immediately you can see the next stage depends on the negative H trigger clock, right? So ultimately here this will remove the race condition, because the second stage must have to wait for the output of first stage and the negative H clock signal, right? By that way you almost remove or overcome the race around condition. So race around condition is nothing but, like, somebody is waiting for, and if both are running at the same time, so they are never going to meet like that way. So this is called the race around condition. So in between, like master and slave, we have to generate a specific time delay such a way that this race around condition can be removed, right? So this is just one of the block diagram of this JK flip-flop. You can see master and slave. This is individually a JK flip-flop. In between you have to put the clock by inserting one of the NOT gate. So first master will be triggered at the positive H clock, and the slave will be triggered at the negative H clock, right? So from that truth table you can see, if J is equal to 0, K is equal to 0, when the positive clock comes, see that this condition is called the hold condition. Hold again is Q0 and Q0 dash, because that depends on the previous output condition. So you can consider this is like a no change. Right, after when J is equal to 0 and K is equal to 1, with the positive edge, see the output goes to 0 and 1, right? So again this condition is called the reset condition, and The complementary of this is like j is equal to 1 and k is equal to 0. This condition, when q goes to 1, this is called a set condition. And the last one, with both are goes 1 1, with the master with the positive age trigger, see, your output is toggle. So previously q is equal to 0, this case q becomes 1, right? And by that way you just toggle your output, right? So this is what about here. You, if even you can go through the timing diagram of this master and slave JK flip-flop, see, ultimately you are going to overcome a kind of race around condition, right? So normally in most of the application we are using this kind of master and slave JK flip-flop, right? Dear students, thank you very much. So what we learn as a part of the summary, we learn about how we can construct the latch, how we can construct the flip-flop, and then different types of flip-flop we have learned is like SR flip-flop, D flip-flop, JK flip-flop, T flip-flop, and master and slave JK flip-flop, just to remove the race round condition, right? Thank you very much. Thank you.